trash is increasing. The trash is increasing. Yes, both in whatever this world is, that at the beginning of 2010 with a landfill that contained 1,400 tons of solid waste, and in our reality here. Yes. Yes. It even says increasing function.
Yeah.
Gosh, College Board with their, I don't know, getting all political about this stuff somehow. I don't know. It seems like it's political in some way. They're talking about the increasing trash. All right. Yeah, solid waste. All right, we're going to use a tangent line to W to approximate the amount of solid waste. So let's do that. So first off, we need to write the tangent line, and our tangent line should include the point 0, 1,400. And it should include the slope that you get when you plug in 1,400 as W in your differential equation, which is what, 1,100 over 25? What is that? 44? That sound right? What? Wow. I mean, it's the same thing as 44. So we got y equals 44t plus 1,400. Easy enough. We can just use slope-intercept because we're given an intercept. And then approximate the amount of trash. I guess it's really solid waste. It doesn't say trash. Solid waste. The amount of solid waste at t equals 1/4, 3 months in. So that'd be 11 plus 1,400. So 1,411 tons of solid waste. That's a lot of solid waste. It is, and it isn't. What? It doesn't say to indicate units of measure, so you don't necessarily have to. All right, did you find your second derivative? No problem finding your second derivative, I hope. Should have been 1/25 of dw dt, which was 1/625 of w minus 300. Everybody agree with that? Easy. And we determined that since this trash is increasing, what do we determine? Well, actually, that's not. It has nothing to do with the increasing. It has to do with our concavity. I should think about what we're doing. At t equals 1/4, we know that our w value was 1411, which makes this thing positive. This thing is always going to be positive, in fact, because this function started at 1,400 for w and is always increasing. So this is concave up, which tells us that the tangent line is an under aspect. Right? And we'd say because concave up. Everybody good there? Good question. I will tell you once we do the last part, how what each part was worth. All right, part C. We are solving the differential equation. So what was it? It was dw over w minus 300 if you separate it equals 1/25 dt. Is that right? Yeah. Okay. And we'll integrate the dw over w minus 300 to get natural log absolute value w minus 300 equals 1/25 t plus your constant. You'll plug in your initial condition, which was t equals 0, w equals 1,400. Get a constant of natural log of 1,100. Then you've got natural log absolute value w minus 300 equals 1/25 t plus ln 1,100. Exponentiate both sides. ln 1,100 just becomes an 1,100. E to the 1/25 t, and we got w equals 300 plus 1,100 e to the 1/25 t. Everybody good with part C? Any questions on that? People, y'all good? To answer your question, no. On this problem, part A was worth 2 points. One for getting a 44 and one for writing, no, one for the approximation of 1411. Part B was worth 2 points, one for the correct second derivative and one for underestimate with a reason. And then part C was worth 5 points, one for separating the variables, one for the antiderivatives, one for the constant, one for solving for the constant, and one for the final equation for W. Everybody good there? Everybody's good with the trash? Solid waste. And then this was the other one we did, right? How'd this one go? Good? Derek, good or no? All right, cool. So first part, pull up these guidelines so that when you ask me here in a second, no, I'll be able to answer. We'll get to it in a second. Use Euler's method starting at x equals 1, 2 steps of equal size to approximate f of 0. So we're starting at 1, we're going to 0. Our initial point is the point 1, comma 0. So our dy dx for the first part of it here will be what? Should be dy dx is 1. We're going to multiply it by our step. Our step, if it's 2 equal steps going from 1 to 0, that step should be negative 1/2. Which, thank you, I got it. I got my arithmetic down, which gives us negative 1/2, which means we should be going from 1 to 1/2 and from 0 to negative 1/2. Everybody good with that? All right. Next, our new dy dx ought to be 1 minus negative 1/2, which is 3/2. We'll multiply that by our step of negative 1/2, which will give us negative 3/4. And we will get an approximation that when x is 1, y is negative 5/4. Right, when x is 0. Thank you. What? No, it just didn't look good. Like a 3 initially. So I tried to make it look. How could that have been a 5? Oh no. Not letting me put the stuff back now. Oh, well. Now I have to rewrite the whole thing because of you, Noah. This is gonna be the last one ever. I'll never do another one again. All right, cool. Everyone good with that? Let's see how many points that was worth. I didn't finish writing it out. Okay. It was worth 2 points. Nothing I like better than guesses. That was worth 2 points. 1 for this work and 1 for the answer. All right, part B. Find the limit as x approaches 1 of f of x over x cubed minus 1. So initially, when you plug that in, you get 0 over 0. Using L'Hopital's rule, you will get the limit as x approaches 1 of f prime of 1 over, f prime of x over 3x squared, which in the denominator will be a 3. And what is f prime of 1? We already figured out what the derivative was when x was 1. What was it? Just 1, so 1/3. And that was worth 2 points. 1 for using L'Hopital's rule and 1 for the answer. Easy enough. The differential equation ones I feel like we're okay with in general. We're doing all right. Part C. Solve the differential equation. So we have dy over 1 minus y equals dx, or 1 dx, right? And what does that give us? That gives us negative natural log absolute value 1 minus y equals x plus c. Our initial condition was that when x is 1, y is 0. So we end up with a constant of -1. And so we should have negative natural log absolute value 1 minus y is equal to x minus 1. And then we will solve. So we got natural log absolute value 1 minus y equals 1 minus x. We'll exponentiate to get 1 minus, or absolute value 1 minus y equals e to the 1 minus x. We'll clear out the absolute value, recognizing that if I plug in a 1 for x, I need to get 0 over here, right? If I plug in 1 for x, I need to get 0 for y. Oh, yeah, if I plug in 1 for x, I need to get a 0 in here for y and make sure this works out. So 1 for x makes the right-hand side 1, 0 for y makes the right-hand, or makes the left-hand side 1, so that works out. I don't need to put the negative in front when I clear off the absolute value. And then we just end up with y equals 1 minus e to the 1 minus x. Good or no? And that was worth the last 5 points. 1 for correctly separating the variables, 1 for the correct antiderivatives, 1 for the plus c, 1 for finding the c, and 1 for the final answer. Good? Yeah, so if you were to determine what interval the solution is valid for, you would look for any discontinuities on your function here, which there are no discontinuities. So this one would be negative infinity to infinity. But if there was a discontinuity, suppose there was a discontinuity at 0 and a discontinuity at 5, we would choose the interval between 0 and 5 for this one because our initial condition was x is 1, which is between 0 and 5. If there was a discontinuity at 3, let's say only at 3, then we'd choose negative infinity to 3 because 1 falls on that. Does that make sense? Everybody good? Zoom?
Good.
Good.
Zoom, good. Okay. Do we feel like we want to do any more of the differential equation ones together? I got 1 no here, 2 no's here, 3 no's here. What? Sure, I guess if you want. No is no. No means no. Yeah. No means no. Noah. I know. You must get told no a lot. All right. Let's see here. So in that case, have we done any of the rate ones? All right, let's do a rate 1 or 2. I know this document says rate FRQs AB, but they sometimes show up on the BC. Some of these were on BC tests also, even though they don't really require any BC material. Did we do the fish one with the rate? No? We did the decomposing grass clippings? That's not really a rate one. It may just be in the Google Drive. Actually, I think I probably put it up in the we're gonna do this fish problem. It's not up in the Google Drive anymore. Part A, how many fish enter the lake from 0 to 5? Integral of the rate at which they enter the lake from 0 to 5. Which was what? 153 if you round to the nearest fish, which is what it says to do. That is a lot of dinner. What is the average number of fish that leave the lake over the 5-hour period? Well, that's just 1 over 5 minus 0 times the integral from 0 to 5 of, what is it? L of t. which is? What is it? 6.059? I don't know. Did it say anything about units, fish per hour? I don't think it said anything about units, but fish per hour. Good with those two? You did not get the second one right? Two separate reasons. Did you set it up correctly? That's the first reason. The scoring guidelines got what Derek got also. So yeah, I don't know. What can I do to help you with that? Okay. Everybody good with A and B besides Noah? He's figuring out why his calculator has failed him on part B. That'll do it. Yeah. All right. Everybody good with part B now? Part C, how do we determine the greatest number of fish in the lake? Well, the greatest number of fish in the lake would occur when the function that represents the number of fish in the lake is at a max, right? And so how do we determine that's at a max? Well, first we got to figure out when it's at a max, right? Or at a min, when it has a critical value. So what's the function that represents the number of fish in the lake? Right, the integral from 0 to t of e minus L, right? That's how many fish are in the lake. There was no initial condition, right? So we'll just go with this. So the derivative of that should be, we'll say this is the number of fish. We'll call that f, like your grade. All right, fish prime then is e of t minus L of t. So we could have a max when this is equal to 0. And so you'd use your calculator to figure out when e of t minus L of t equals 0. That came out to be t is 6.20356. Try not to round until the very end of the problem. And then you'd also need to check what? Check the endpoints, right? So we need to check at 0 and also at, what is it? Is it 8? Yeah. So we're going to check at 0. We're going to check at 8. We'll plug 0 and 8 both into this. If we plug in 0, the value of the number of fish is 0. So it's clearly not going to be 0. But we'll plug in 6.20356 and we'll plug in 8. And looks like the largest value is at 6.20356. I'll make a little chart here. At 0, there's 0 fish. At 6.20, I'm just going to round it now. We had 135 fish. And at 8, you had 80 fish. 1998. Good. No, you've got to check the endpoints. One of the points is, yeah, I think you would have not got the points for the justification. You would have got the points for setting it equal to 0. You would have got justification for the points for the answer, but not for the justification because you didn't prove that both endpoints were lower than that critical value. I guess, well, if you had a sign, you said you had a sign chart? Yeah. Yeah, if you had a sign chart that shows that was a max, then that's probably fine. Yeah. Some kind of justification there. As long as you stated that it was a max from there, then that's fine. Everybody good with C? Yeah. All right, part D. Is the rate of change in the number of fish in the lake increasing or decreasing at 5? So what's the rate of change in the number of fish in the lake? That's E minus L. Right, so we just need to figure out what's E of 5 minus L of 5. What's E of 5 minus L of 5? Oh, sorry, not the rate of change of. is the rate of change in the number of fish increasing. So we need E prime of 5 minus L prime of 5. We want to know if that function E minus L is increasing or decreasing. So E prime of 5 minus L prime of 5, what does that come out to be? Negative something, negative 10.7228, which is less than 0. So it'd say it's decreasing. Good? Yeah, good. The second derivative of f? Yeah, the second derivative of f is still this. Yeah. Yeah, because first derivative is E minus L. So the second derivative is E prime minus L prime. Yeah.
For D,
Yeah.
Why wouldn't, or like, would it be possible to just do E minus L as the function and then find the derivative of that?
Yeah.
Okay, because I did that. I got like a different answer, but like it was still negative. So I don't know if it should be the same answer.
It should still be the same when you evaluate it at 5.
Oh well.
I mean, E prime of 5 minus L prime of 5 is the same as the derivative of E minus L evaluated at 5.
I may just put it in my calculator wrong then. Sorry. Okay, thank you.
Yeah, or make sure you're in radians, not degrees or something like that.
Okay. Thank you.
Yep. All right. Everybody good with that on that? Yeah.
Mr. Bachelor, I'm a little bit confused. Could you go back to the last slide?
Sure. Here it is. Here is the last slide.
Okay, so isn't E itself the rate function?
Yes.
So if they're asking for the rate of change in the number of fish, wouldn't it just be E of 5 minus L of 5?
No, they're asking for, is that rate of change increasing or decreasing?
Oh,
so we're
okay.
determining if the derivative of the function that represents the rate of change is positive or negative.
Okay, I see. Thank you.
Yep. Everybody good now? Zoom, everybody good? People here seem to be good. All that extra time I gave Noah, he was able to figure it out. That's excellent. All right, should we do another rate, or are we ready to move on to like some series ones to just start practicing with series ones? You guys want to do another one similar to this? Another one similar to these? Okay. Let's see. What do you guys want to do? Escalator, bananas? Escalator? All right, escalator it is. Got something against bananas. 2 minutes, ready to go. How many people enter the line for the escalator? Well, that's just the integral from 0 to 30 of R of t. Luckily, your calculator will do that for you. What did it come out to be? $207. Sounds good? Oh, sorry. 300. 300. Wonderful. 270. Yeah? That was worth 2 points. One for the integral, one for the number. Everybody go with A? A is pretty easy. Yeah. Okay, part B. During the time interval 0 to 300, there are always people in line for the escalator. How many people are in the line at t equals 300? Well, we got 2 different things we have to deal with here. One is that at the beginning, there were already 20 people. And then how many people entered the line in those 300 seconds? Well, 270. And how many people left the line? 0.7 of them every second. Right? So minus 0.7 times 300. And what did that come out to be? 80. Sounds good to me. Easy enough? That's pretty easy. That was also worth 2 points. 1 point for considering the rate out and 1 point for the final answer. So the assumption is you probably, if you only got 1 point on that, you probably forgot that there were 20 people to start with and you only got 60 as your final answer. Yeah. Hopefully that's not the case. All right, part C, for t greater than 300, what is the first time that there are no people in line for the escalator? So how are we going to figure that out? Oh, 300 plus 80 divided by 0.7. Yeah. Sorry, I thought you said 300. I thought you were saying 300 plus 80. Yes. 300 plus 80 divided by 0.7. 80 divided by 0.7 tells you how long it takes for those people to clear out. We were already 300 seconds in. So what did that become? 414.286. Sounds good to me. B and C are like the easiest questions I feel like you could get. There was no calculus involved with any of that. Yeah, I mean, you didn't have to write out any calculus. You didn't have to do any integrals. I mean, you could have. You could have integrated the 0.7 to get 0.7t and then 300 times that. That is correct. Yes. My point is, B and C were pretty easy. All right. Anyway, part D. Yeah, I didn't have room up here. Relax. No. All right, part D. Part D, for 0 to 300, when is the number of people in the line at a minimum? That could occur at either of the endpoints, or it could occur at any critical values of a function that represents the number of people in the line. What's the function to represent the number of people in the line? 20 plus the integral from 0 to t of, what was it, r? Is that what it was, r of t? Minus 0.7, right, was the other, yeah, dt. So that's the function to represent the number of people in the line. So we want to know when is that at a minimum. So we take the derivative of it, which is just r of t minus 0.7, set that equal to 0. And when did that equal 0? Two different times, t equals 33.0133298 and 166.574719. That's what you guys got? Yeah. You did not. Yes, you are, but the overall rate between entering and leaving. Yeah, subtract that 0.7. So then we make a chart and you test 0, 300, 33 point whatever, and 166 point whatever in your chart. At 0, we knew it was 20. At 300, what do we have? We have 80. And so then you just need to find those other two values. They came out to be 158.070 and 3.803. So looks like at this value was our minimum. And they asked, what is the number of people in the line and what time? So we'd say, this is the time, and the number of people to the nearest whole person, it said was 4 people. Good. Any questions there on D? How do we feel about the rate ones now? Do we still want to do another one at some point? Eventually. Okay. All right. That's going to be it for today because we have like 5 minutes. So for tomorrow, why not? For tomorrow, we'll do one more of these rate ones. So do the banana rate problem. The banana rate problem, which is in Google Drive, banana rate, the banana rate banana problem. And then let's look. let's see here. Where are the series FRQs that I posted? It's been a long time since we've looked at those series FRQs, hasn't it? There they are. Yeah, just the banana one for the rates, yeah. Oh man. All right, which one? Anybody remember which series ones we already did? We probably did all of 2015 and 19, I'm guessing. All right, so then let's look in this 2011 to 2014. So for tomorrow, why don't you try to do the banana problem, and then I don't know, just the first two in this 2011 to 2014. So for those of you that are at home and can't see this one right here with this graph, and then natural log of 1 plus x cubed. Sound good to everyone? Everyone's good there? People in the Zoom, you good with that? Banana, series graph thing, natural log of 1 plus x cubed one. Great.
Good.
Zoom, good.